And okay. All right. Start your float, Q. Thank you. Thank you, Q. Oh my god. I forgot again. Let's go, Q. All right, let me do that really quick. I don't know how I do that every time. Um, but that's why I have all of you to help me, so thank you. Okay. Um okay. Workshop number 7. 7. Boom. 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 All right. Okay. Right, and call it. Cool. All right. Started the float. Thank you so much, Q, for the reminder. You're an absolute legend. Bread says, yo, 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 love the new profile picture. Hey, thanks, Bread. Thanks, mate. That's great. I'm happy you like it. I freaking love it. Okay. Cool. Yeah, so as always, we'll get started in like 3 minutes here. Just to give people some time to roll on in. How's everyone doing, though, on this Wednesday? People tired? Having fun? Excited? Lots of energy? Sad the boot camp's almost over. Happy you're not going to have to deal with me anymore. The boot camp flew by so quick, it's wild. I know, Brett. It's insane. So crazy. And it's weird because like starting in June, we're just gonna do the same thing over again. All of you are gonna come back in here. It'd be funny if you came back in here and you'll hear me saying the same stuff I taught all of you. It's almost like when you go back to like high school and like you walk into your old teacher's classroom and they're still teaching the same thing. It's like kind of sad in a way, nostalgic. But the good news is that we're gonna have a FCL boot camp coming up in a month or two, and when we do that, you'll all be able to participate again, and that's gonna be awesome. All right, so we'll get started in 1 more minute, and then we'll be off to the races. Also, yeah. So the good thing about today is that it's actually probably the easiest day. So if you're tired or your brain's hurting, don't worry, it's not that hard of a day today. And we may even end early, but I always say that, and then we end up going over. But so we'll see. Also, as we're approaching the end here, I want to continue to give so much love to all of our instructors. They're even here. They're still coming. Thanks, instructors, for coming. So dedicated. It's amazing. All right, so let's get started. Let me share my screen. All right, here we are. Workshop number 7. Welcome, ladies and gentlemen, to another day. This is our second to last workshop, so we're almost done. I'm pretty sad. I'm going to miss all of you very much. You've all been such an amazing cohort. But yeah, let's just get right into it. So we're on chapter 5, woohoo. That's the last chapter of all of them. And there's only 3 days. So today we're going to cover 1 and 2, and then on Friday we're going to cover day 3 and complete our NFT contract. So in the last workshop, we left off working on our NFT contract. We're actually going to put that aside today, so we're not going to talk about that much because we need to cover some other concepts before we actually dive into that. So the two concepts we need to talk about are pre-post conditions and events, and then the other one is contract interfaces or standards. So let's just dive into this day first. And this is arguably the easiest day so far. So let's just let's just do it together. So if we have a blank contract here, I'm just, and also I apologize. I'm sick right now, so if I keep coughing, then please ignore. But yeah, let's just go ahead and make wait, what did I do wrong? Oh, contract. Let's just go ahead and make an empty contract, and yeah. So the first topic we're talking about is pre and post conditions. So what the heck is that? Well, pre and post conditions are things that you put on functions. So let's make a function. Also, hey W Falcon, good to see you. Called add numbers. Okay. Add numbers. Okay, and so what we're gonna do is we're gonna pass in an x, which is an integer, and y, which is an integer. So there's these things called pre and post conditions you can put on your functions. So preconditions are defined like this, and what they are is they're things that get run before the function actually gets executed. What's up, Ricardo? How you doing? So inside of this precondition, what we can say is, you know what? We only want to be able to call this function if x and y are both positive, right? So let's just say add positive numbers. So we want to panic or abort the program if one of these is negative, okay? So we can say is if x is x must be greater than or equal to 0 and y must be greater than or equal to 0. Otherwise, we're going to panic and say, hey, both x and y must be positive, okay? So what you do is you put the condition that must be true, okay? And if it's not true, it'll put this condition. So let's just go ahead and deploy this. And if we were to go to a script, let's try and call that function. So let's just get rid of this. Let's import hello world from the first account. And let's just call hello world dot add positive numbers. And let's pass in 0 and 1. So if we do this, it should succeed and just nothing will happen, right? Boom, so it's fine. But what happens if we put in -2? Well, if we execute, it's going to say, hey, both x and y must be positive. So preconditions are basically restrictions that have to be put on your functions, or that can be put on your functions to make sure that some condition is true if someone's calling it, okay? And you put your precondition at the beginning. So if we were to do other stuff like, let's just return x plus y, that goes after. And so, let's just put like a, int for the return value. That goes after. So preconditions are always defined at the beginning, and you can never put anything before them. So you can't do that. Now, post conditions are sort of similar to preconditions, except they get run after the function's over. So what you can do is you would think that you would put the post condition like down here, but that's not true. You also put the post condition at the top. So even though it's confusing because the post condition will get run after the function's over, you still put it at the top, but after any preconditions, okay? So let's say that we're now returning an integer, right? And they're both positive. So let's just get rid of the pre for now. And let's say add positive numbers, okay? So we have to say, you know what? The result cannot be negative, okay? So if we want to access this result, how do we do that? There's this keyword actually called result. So if you type in result here, you can say result must be greater than or equal to 0. Otherwise, x plus y is not a positive number, okay? So, again, you may be asking, what does this result mean? Well, result represents whatever the return value is. So in this case, it's going to take an x and y. It's going to go right to here, right? It's going to add x and y and return them. And it's going to return that as the int. And then the post condition will run and say, okay, is that result greater than or equal to 0? If not, then panic and abort the program. So let's deploy this. Wow, this is interesting. I've never seen this before. All right, that must be an update. All right, cool, Flow Team. All right. Maybe we also fix some of the other problems. That'd be hype. All right, so let's try it. So, oh, and you know what else I want to try? Let's try and log, like, hello right here and see if this gets run. Okay, so let's redeploy and let's go to the script. And now let's call these two. So if we have -2 and 3, right? -2 and 3 is going to be a positive number. So this should work. Okay, so let's try it. Oh, because I have to return this. Wait, let me try and mute whoever is. Okay. So let's just return this integer. All right, let's try it. I'm going to do some very bad things. Okay. Let's execute, and we should see that we get hello, right? And then we get 1, right? So perfect. -2 plus 3 is 1, so it's totally fine. But let's try and add -2 and 1, right? This is going to return -1, and this should be a problem. So let's try it again. And it says post condition failed. X plus Y is not a positive number. So you'll notice the reason I put this hello world here is because it didn't even log this hello. And the reason for that is because, remember, when you panic, everything gets removed. So everything gets aborted. So even though it technically did log this, and then it returned this, it said, wait a minute, -2 plus 1 is -1, which is not greater than or equal to 0. And so we're going to panic, we're going to run this line, and we're also going to undo everything that we did previously. So what that means is, for example, let's say we had public var number is an integer, okay? And we say self.number equals 0, all right? So in this function, we're going to say self.number equals 1,000. So what's going to happen? Okay, let's confirm this again. Oh my God, please. Okay, so we deployed it to the second account, I guess. But let's go back to the script again. So do we have any guesses? If we run this function, right? If we execute this function, add positive numbers with -2 and 1. Anyone have any guesses on what the value of number is going to be after that after the function call? 0. And why is that, Ricardo? Abort. Exactly. Yep. Great job, Numini. Also, love your new profile picture. Exactly, Ricardo. So what's going to happen is it's going to call this function, right? It's actually going to update number, and then it's going to go to the post condition. It's going to fail, abort the program because we're panicking, and then it's going to undo any changes, so number's going to go back to 0. So boom, you got it. That's pretty much it for pre and post conditions. Actually, no, just kidding. There's one more. So the one other thing I want to talk about is the before keyword. So let me actually scroll down to the example I use here. Okay, yeah. So what you can also do in your functions is let's say we have a new function called public function update number. All right. And in this function, we're going to say self.number equals self.number plus 1. So it's pretty simple, right? If you deploy this contract, number is going to get initialized to 0. And then when you call this function, it's going to say self.number equals self.number plus 1, right? So pretty simple. It's just going to add 1 to the number. But what you can do is, and I don't know, I've never really seen this used actually. So like, I don't know how important this actually is, but I'm just letting you know that it's here. In your post condition, you can actually access the value of a variable before the function was run. So you can do that with the before keyword. So you can actually say before self.number equals self.number plus 1. Otherwise, this function didn't do its job. And I'm just going to put this on a new line so you can read it. So what this is going to say is, the value of the number beforehand must equal self.number plus 1. Now, does anyone have any ideas? If I call update number, what's going to happen right now? It's going to update the number. Ricardo says yes. Let's see what Bam says. Bam says no, and Bam would be correct. Let's actually try it. Well, we're updating states. We have to actually do this in the contract, but oh, I was gonna say I was so scared it didn't save. Let's redeploy. Let's go to a transaction because we're changing state, and we're gonna import from 2, and we're gonna go to the execute, and we're gonna say hello world.update number. All right, let's try it. Uh-oh, this function didn't do its job. It's because it was a trick question. Because self.number is getting updated by 1. This actually has to be -1. Because the before value equals the new value minus 1, since we added 1 to the new value. Yeah, this is a trick question. Yeah. So again, before accesses the value of the variable before the function, and this, this obviously is the value of the variable after the function's called, because post is after the function gets run. So yeah, that's pre and post conditions. I think that's all I wanted to mention. Cool. All right, so let's talk about events now. Oh, let me put the little thumbs up in the chat. So why do we do something like this? That is a awesome question, NJ, and I will tell you once we get to the day 2. So this is, you don't really have to understand why, just understand the syntax right now. But the reason I'm teaching you this is to lead up to the next day. You'll see. But the short reason is for standards or contract interfaces. But yeah, we'll get there. When did you change your profile picture? I changed it like a couple hours ago. Bam. Do you like it? Me holding a nice little emerald. I know, it's amazing, right? Whoever made it is super cool. Ricardo said if you had written self.number equals before... Yep, exactly, Ricardo. Yep. The math wizard. So, yeah, remember back to middle school when they teach you... What is it? What is this operation? I don't know, like add 1 to both sides or something. But yeah, that's totally fine. We could even do some more complicated math. 2 times both sides. Nice. That should work. And then divide both sides by 3. Let's see what happens. If my middle school maths are correct, this should work. Hey, nice. So if you want to check, this is another way of doing that. I don't know why I just did that. 3 ETH. All right. Cool. So wait, what was I talking about? Oh yeah, events. All right. So let's get rid of this because whatever, and let's talk about events. So what are events? Well, events are not, we're not going to really talk about them that much in code. So we're going to kind of go back to reading again. I know reading's really boring, but stick with me here. But let's just read through this together. So I'm going to increase the font. So events are a way for a smart contract to communicate to the outside world that something has happened. So for example, if we mint an NFT, we want the outside world to know that an NFT was minted. Of course, we could just constantly check the contract to see if the total supply was updated, but that's really inefficient. Why not just have the contract tell us, right? So what I really mean by that is, there's often a problem in contracts where, you want to know what happened, right? If you want to, know in your DApp or in your application that someone minted an NFT, there's no way to do that unless you just manually check if the total supply increased, right? So a better way to handle this is to, broadcast, or in other words, emit events to the blockchain. And what that will do is that will tell the blockchain that something happened, and then your applications or your dApps can listen to those events and do something upon that action. So let's take a look. So let's say we have a public function called mint NFT, okay? And so we're not going to actually implement this function because that would require too much time, and that's not the point of this lesson. But let's just say that, this mints an NFT, and we'll just log, we minted an NFT. Yay, okay? So how do we actually tell the outside world that an NFT was minted? Well, we can define an event. So let's say public event, minted NFT. And by the way, it's standard that all events begin with a capital letter. So make sure all your events begin with a capital letter. And also, events are always public. So, never put like an access self or something. That doesn't make sense. So events are always public. And in fact, I don't even think they can be any other keyword anyway. So it's like contract or resource or struct. All right, excuse me. Cool. So this is an event, and what we can do is we can actually put some parameters inside here. So let's just say the ID of the NFT is a UN64. Let's say the name string and maybe like a description, right? So these are pretty common. So there's our event right there. Now, how do we actually emit it? Because right now nothing's actually broadcasting it to the blockchain. So what we can do is inside of our function here, we can say emit minted NFT and then pass in all the parameters. So the ID, let's just say is 1. The name is, let's say Kelcoin or Kel token master coin. None of you will get that joke. It's a guild leader insider joke, so get wrecked. And then the description is going to be, BAM is really cool. Not. All right, awesome. So now that we have this event, what we can, we emitted it, right? So now what's going to happen is when we call this function, it's going to emit this event to the blockchain. So all of our applications and dApps can read the blockchain and be like, oh, wait a minute, an event was emitted. Yay, we can do something now. So let's go ahead and deploy this contract. And I don't even know if the playground will do this correctly. Like, I don't even know if the playground will ever do this, but let's just try it. So let's do hello world. Mint NFT. Honestly, I don't even think the playground does anything, but let's just test it out. Okay, well, it's being buggy. I don't have the time. Okay, I can't. Whatever. Oh wait, no, it actually does. It says emit event is not supported. Yeah, so for some reason the playground doesn't support events. But anyway, the important part is that just to understand this from a more conceptual point of view, that whenever you're building smart contracts, or you're ever, like literally whenever you're making smart contracts for a production environment, I can't emphasize enough how important events are. Now, I'm going to pause here and actually show you a real world example of why this is so important. So let me actually show you the float contracts. So all of you know float at this point. I'm not going to waste time introducing it, but this is the contract for floats. So look at this, by the way. Oh my God. Woo! Cadence, yay! I'm so smart, it's insane. Look at all that. Wow. Oh my God. Shee. Crazy, right? Okay. So yeah, that's the contract. Anyway, but look, these are all events I defined. So float minted, float claimed, float destroyed, float transferred, float purchased, float event created, float event destroyed. So let's actually go to floats.city/live. So now that we know how, what events do, does anyone have any guesses how this page is working? So for those of you that don't know, this page is where, like floats that are claimed appear on this page in live time. So anyone have any guesses how we're doing that? Events. Yep. Oh, look. See, look. A float was literally just claimed right now. Right there. See? Exactly. So you all got... Oh, look. Here's some events. Right? Cool. And for the record, we also log the events in the console. So look, each of these is an event. So let's see, right? Oh, look, here's more NFTs. So let's look at each one of these, right? So what does this one say? Let's bring this out a little bit. So look, here, there's a little object called block event data. So what's in here? Event host, event ID, event image, event name, ID, and recipient and serial, right? Oh, look, let's go back to our contract. Flow claimed. ID, event host, event ID, event image, event name, recipient, and serial. The same exact thing that's right here. So this is exactly how we're doing that. Now, just a slight disclaimer, we didn't do this ourselves. There's actually a service called Graphel. And Graphel is actually like a really amazing, service. So let's actually go and look at Graphel. They're a service that actually will read event data for you and broadcast it to your web page. So we simply set this up, but they do all the hard work. But, to give you just to, help you understand like real world applications, they're using events and they're reading events from blockchain and broadcasting it to you. So that's exactly how this page is working. Yep. So I don't know. I like showing that because I always think it's really cool to show like, you know, what these things do in the real world. All right. So anyone have any questions on events? They're a pretty interesting topic, but pretty simple in code actually. So I'm gonna put a little thumbs up. Make sure you thumbs that or thumbs up or thumbs down that. And if not, we're gonna move on here to the next day. It is cool to see in the real world. Yeah, right. It is cool. And you're gonna be surprised when we actually do our NFT contract tomorrow. You're gonna see like how real all this stuff actually is. Why aren't you interacting with events directly from the blockchain? Turbo, I'm assuming you're asking why we're not why we're doing it, like why we're not just doing it ourselves and why we're using Graphel. The reason is because we could would you need to, yeah, see, like the thing is that we would have to just set up like a loop in our code that constantly like looks for events and then like stores them somewhere for like a 10-second period. So it can be like a little bit of nuance, although truthfully it's not like crazy difficult, but it's just much easier to use Graphel because what they're doing is when you set up an indexer, which is basically like you tell Graphel you're listening for a certain event, they will actually store all the event info for you. So that way, like if you ever want to read the event data again, like they store it somewhere. But for our use cases, it's just really easy because they do the work of pulling it in and sending it to us, and then we can just simply display it. Yeah, it's mostly convenience. Yeah. You're welcome. Yeah. And we're going to be using actually Graphel for the Emerald bot as well. So right now, you know, all of you, if you have like a certain role in Discord, you know, the role doesn't get taken away when you sell or buy the NFT. But pretty soon, you know, we're going to be launching the Emerald bot in the NBA Top Shot and UFC Strike Discords. You know, and that's kind of why I announced the Dapper Wallet thing today. And once we do that, the bot's gonna actually use Graphel to like automatically take all your roles away if you sell or buy NFTs. You like if you don't have your NFT anymore. All right. So let's go ahead and jump right into contract interfaces. Yeah, right, Ashley? All right, let me just see what I wanted to do here. Okay. Cool. So what I'm going to do today is I know this is a little bit weird for us, but I'm actually not going to use the playground today for this part because it's actually really nice. For a little bit of context, the last time we did this boot camp, the playground was broken when I did this lesson, and I realized how much easier it is to actually do it in VS Code. So I'm going to show you in VS Code, and hopefully you'll be able to follow along. So I'm going to make a new contract called Hello World.cdc, and then I'm going to make another contract called iHelloWorld.cdc. So what this is going to be is two different contracts. I'm going to put them side by side. So boom. So here's Hello World.cdc. So this is the contract, and this is the contract interface. So can everyone see this all right? Is the text big enough? It is? Okay. Raven says one more. Okay. So hopefully that's all right. All right. So inside of here, let's go ahead and make a normal contract like we usually would. All right, and then init. Perfect. So we have a contract right here. So now we're going to talk about contract interfaces, which is a little different, where it's called pub contract interface iHelloWorld. So that immediately looks different, right? Why does this have interface in front of it? Well, it's... Oh, okay. I'll go back, Raven. So yeah, so look, this one has interface in front of it. So, you know, to be clear, this is also a contract, and you can notice because it's, you know, it's in a separate file, right? But this is it is a contract. It's just also an interface. So what happens is that in this contract, a few things are true. Just like, you can think about it actually like this. Like, remember when we had public resource test, right? And then we had like a public resource I test or a public resource interface I test. And if you had like, public let ID be an int and this implemented that, then it's going to give you an error, right? Hey, it doesn't conform. And you have to put public let ID int in here in order for it to be okay, right? Well, it's actually the same exact thing with contract interfaces, except it's at the contract level. So it's not resources, it's contracts. So inside the contract interface here, if we put public let total supply like this, notice, by the way, that it's not telling us to initialize it. Does anyone in the chat know why it's not telling us to initialize this like this? Why aren't we doing this right here? Yeah, because it's interface. Exactly, Turbo. So remember in interfaces, or like we learned in resource interfaces, you don't ever actually implement the functions. Yeah, so all those things only happen in the actual contract, not the interface. So the interface is saying, hey, you have to have a total supply. So in this contract, let's just say import I hello world from /I hello world. Now, remember, usually you would see this as an address, but because we're in VS Code, it's just all local. So if we implement this, we have a problem. Contract hello world does not conform to the interface I hello world. And, well, it's pretty self-explanatory. It's because we don't have the total supply. All right? And then, obviously, in this contract, we definitely have to initialize that. So you can see that just like resource interfaces, contract interfaces are a way for us to tell, hey, you definitely need this thing. So in addition, we can also put public function update total supply. And in here, do self.totalSupply equals self.totalSupply plus 1. Oh, wait, I made a mistake. Oh my God, I actually didn't mean to do that. I just kept going. We can't do that because it's the interface, right? But the idea is that in here, you would do that, right? So you actually have to do that. Let me just change these to var so we can change them. All right, cool. So, and again, if we didn't have this, for example, it would say, hey, you need it because, it's on this side as well. So, back to, who asked this question? I think it was Njai, right? That said, why do we need pre and post conditions? I'm looking back to it. I can't remember. I think it was Njai. Yeah, so I think Njai, asked before, well, what the heck are pre and post conditions for? And I'm going to answer that now. So the reason for pre and post conditions is because even though, look, it's already giving us an error. See, in both contract and resource interfaces, you're not allowed to implement them, right? Like we can't put anything in here, or else it's going to give us a problem, except for pre and post conditions. So we can put a precondition in here or a post condition inside of here that says self.totalSupply equals, or we can put a post condition that says before self.totalSupply equals self.totalSupply minus 1, or equals. Otherwise, say the implementing function did not do this correctly. So why is this helpful? Well, it's because this is saying that any contract that implements this interface must not only define a function called update total supply, however, that function must also update the total supply correctly. So what that means is on this side, right? Turbo says one at a time. Yeah. So that means that on this side, if for some reason this contract tried to do plus 10, this function would never work. Even though there's no post condition here, it's actually still going to use the post condition from this one. So this function will never work because it updates it by 10. So by doing this, you make sure that the implementing contract does it correctly. Now, of course, this contract can do other stuff. Like it could say like self.coolest person ever equals Jacob, right? Like it could obviously do that too. But as long as it's abiding by these things, that's okay. So that is why pre and post conditions. It's because we can specify them in our interfaces and make sure that all the implementing people do it correctly. Now, this doesn't seem too important, but it gets a lot more important when you start thinking about standards, right? So this is sort of like a really, really, really important conversation, and why we're having this conversation before we finish our NFT contract. It's because, actually, let's just go and read it from the chapter directly. Here, so contract interfaces as standards. So why do we talk about this? Well, let's read through this a little bit together. So contract interfaces, exactly, Ricardo. Yep, exactly. So this says contract interfaces allow you to specify some requirements on an implementing contract, and additionally create standards on what certain contracts look like. So in order to really like think about this in your head, think about NFT contracts, right? On Flow, every single NFT contract must have a total supply. Why? Because the NFT standard says so. Now, the NFT standard is another way of saying the NFT contract interface. So let's actually look at it together. So let's go to GitHub. And this is where the Flow team actually stores the NFT standard. So if we look at this contract, you'll see it's public contract. Let me increase the list a little bit. It's public contract interface non-fungible token. Now, another way to refer to this is non-fungible token standard, because inside of it, it says you have to have a total supply. You have to have a this event. You have to have this event, this event. You have to have an NFT resource. You have to have, a collection resource. You have to have this function, right? And look, even in this function, it's saying a post condition. So it's even putting that there. There's some preconditions in some of these functions, right? So there's even a post condition here that says, well, hey, when you call the withdraw function, the returned NFT ID must equal the one the user requested. Now, the reason for that is obvious, right? Because if, for example, a user said, hey, I want to withdraw an NFT with ID 0, maybe they're purchasing it or something, and instead the, person that implemented this NFT contract was a total, a-hole, they would return an NFT with ID 1000, right? And then all of a sudden, the user isn't getting the NFT they wanted to. So this prevents that from happening. Now, of course, it's not exhaustive, and there are obvious ways of hacking this, but, it's just a step in the right direction. So anyway, this is the non-fungible token standard. And so every single NFT contract has to implement this. So let's look at Float, for example. Let's go to the Float contract. Look at this. So in the Flow contract, you'll see it implements non-fungible token, right? And so that way, it's an official contract. It's an official non-fungible token contract on the Flow blockchain. So you'll see it has a total supply right here, right? Total supply. It has a NFT resource right here. It has a collection resource right here, right? So all these things that it says we need to have are here. And in addition, right, we need to have a withdraw, deposit event. Do we have those? Yep, we do. Deposit and withdraw right here. So that's what standards sort of are. And I hope that this sort of gets you thinking in that sort of direction. All right, so let's but before we like wrap up this discussion, because that's sort of like all like the conceptual stuff for today. Actually, you know what? Before I move on, does anyone have any questions around that, like from a conceptual point of view, what a standard is or why we need them? No? Cool. And but I'm more than happy to answer questions about this because it's not really on the coding side, but it's more just from a general point of view. And also one more thing I will mention is that standards are not just for like security reasons; they're also for readability purposes. You can imagine that, for example, when Blockdo needs to read information about your NFTs, they need to read the total supply of the contract. So how does Blockdo know what the total supply is? Well, they know it because every single NFT contract must have a variable called total supply. So it's really easy for them to read that because they know it's there and they know what the variable is called. If there was no such thing as a non-fungible token standard, Blockdo would have no standardized way of finding that information, right? They would have to look into every project and figure out what the variable is to read that information. Now, where I'm getting with this is metadata, right? And metadata is by far the biggest problem on the Flow blockchain because reading metadata in a standardized way is so difficult. But if any of you have ever heard of the metadata standard, again, the standard keyword in there, that's a standard being developed by Biartec. And that's a way for people to discover information or metadata about non-fungible tokens in a standardized way. So if any of you are ever curious, not to like self-promote my own channel here, but I think it is actually pretty helpful. There's a video I did with Biartec. I don't even know how long ago or even where it is. Oh wow. It's probably way back here. I don't even know where it is. Let me actually look it up. Oh yeah, right here. So there's a video I did actually. I'll link it in the chat. Again, I'm not trying to self-promote or anything, but it is a really, you'll learn a lot about NFTs actually if you watch this. But that's Biartec right there. That's me, and we basically talk about the problems with metadata on Flow, and how to fix this problem and how he's fixing this problem. So it's focused on how do wallets like Blockdo, Dapper Wallet, and Lilyco, how do they know how to read information about NFTs? Because everyone has their own metadata, right? Everyone has their own information. So how can we look at them in a standardized way? And that's, if you want to dive into that topic, you're more than welcome to go into it. Yeah. So I know I just rambled, but I can't stress enough how cool and difficult and, interesting these topics are. So Raven says, when the permissionless event happens, won't people stop complying with the standard? No. So it is true, Raven, that people, actually, that's a great question, Raven. The reason for that is because, I'm assuming the reason you're asking that is because, like, right now, when you deploy an NFT contract, the Flow team has to tell you, yeah, like, you're fine, you implemented it. But, if someone tried to not implement it, the Flow team would say, hey, you have to do that. So the answer is yes. Technically, people could do that, but it would not be in their best interest to do so. And the reason for that is because wallets only will manually support projects that do. So if a project ever doesn't implement the standard, wallets like Blockdo and Dapper Wallet and Lilyco, they'll never display their NFTs because there's no way to read them in a standardized way. So it screws the project creator for sure. Yeah. All right, so I hope I didn't just completely dive off a deep end, but anyway, yeah, that's it. So we're gonna conclude today with a more of the technical stuff. So thinking about not just simple variables and functions, but also resources, right? So let's dive into it for a second. So let's think about resources, right? So let's say in this Hello World, we also have a public resource called NFT. All right, and inside of this NFT, we're going to have a public let ID, UN64. Okay? So pretty simple. So we're going to say, you know what? Every contract that implements this has to have a resource called NFT, and it has to have an ID of this. So let's see. This contract now is an error. Does not conform to the interface. Well, why not? Well, obviously, because it does not have the NFT. And this is not enough. We also have to have the ID. All right? And so let's initialize this and just say self.id equals self.uuid. Cool. So now we're fine. And this is all awesome. But let's take it one step further and make things even more complicated. So let's say in this interface, in this contract interface, let's say we have a resource interface. Wow, things are getting confusing. Okay. I'm going to call it INFT. Now in here, we're going to have a public let ID, UN64, and say that this NFT has to implement that. All right. So now what we've done is we've defined a contract interface that has a resource interface called INFT and a resource called NFT that implements INFT. All right. So we now get an error. All right. And the error is resource hello world NFT is missing a declaration to the required conformance to resource interface, I hello world.inft. So can anyone tell me in the chat? I'm going to give you a couple minutes to do this. Can anyone in the chat tell me how do I fix this error on the left-hand side? Implement INFT. So Yes. So the answer is yes. Okay, yeah. So Ricardo already got the trick. So what I wanted to do was I wanted someone to mess up and say that we had to do something like this. All right. And I wanted them to do this. Why is this not the solution? Why is this not good? No, Ricardo, you're too smart for me. But can anyone tell me why is this not good? It's tricky. It's a different interface, exactly. So when we think about types in Cadence, we have to match up the types exactly, or else there's going to be a problem. So what's actually happening here is if we look at, let's just revert this for a second. On this right-hand side, this contract interface is saying, hello, we have a resource, NFT here, that implements INFT. So this type is specifically this resource interface. So on this side, when we actually go to abide by that, we have to make sure we're implementing the same type, which in this case is iHelloWorld.inft. And now we're okay. And you might be asking, well, don't we also have to implement the resource interface? No, we don't. So in contract in the actual implementing contract, you never have to redefine the resource interfaces. So you don't have to do this. So to show you an example, let's go back to the non-fungible token standard. Here. Let's go to non-fungible token, and let's look at an example implementation. So in the non-fungible token interface or standard, you'll see that there's a couple interfaces here. There's the provider, there's the receiver, and there's the collection public. And it's saying all these interfaces have to get put on the collection, right? So provider, receiver, and collection public. But if we look at like an implementing contract, so a contract that implements non-fungible token, let's scroll down. Does it ever copy and paste any of those? There's the answer is no. There's no provider, there's no receiver, no collection public in here. But on the collection, it implements non-fungible token.provider, non-fungible token.receiver, and non-fungible token.collection public. So you can see that's where the difference is coming in. You have to make sure you match up the types exactly like we do in this example. So how's everyone doing? Pretty good? Thumbs up or thumbs down? And by the way, that's all I have for today. I think, right? Yeah, that's pretty much it. All right, looks like everyone's good. So yeah, I told you today wouldn't be too hard. This was all really in preparation for tomorrow. And tomorrow, what we're gonna do is we're gonna take our NFT contract that we made and we're gonna make it implement the non-fungible token standard. And that way it's an official NFT contract on the Flow blockchain. And then we're gonna deploy it to testnet. Oh, sorry, Friday. I don't know why I said that. Thanks, Q. You always got me. And also, I remembered the float. Okay, so I'm remembering to send the float link. Let me do that. Thanks again, Q, for reminding me. For some reason, I naively thought that this would be checked during the execution of the Cadence virtual machine code. Oh, yeah, no. So, yeah. All right. So let's go ahead and enable it. I'm going to resume it. And the password is hello, BZ. All lowercase. And no spaces. Naive person. True. All right, it's open. So the password is hello BZ. And let me send the link. I'm showing the code on my screen. I don't want to type it in chat in case anyone else sees it. All right, so while we're all doing this, let me just go over a few administrative stuff. So as you all saw in the announcement, let me actually pull up the announcement here. So in the announcement, you'll notice that, when does this boot camp end? This boot camp ends on May 29th. Okay. So, on this Sunday, again, we have our last workshop on Friday. But how long do I have to submit my quest? So a lot of people, ask me about this. So, please try to submit your quest before Sunday. However, because we know it takes time to make good quests, and I know that you're all trying your best and you all have, busy lives to live, you have until June 5th to get your quests in and receive your final certificate float. If for some reason you can't make that deadline, it's okay. Just please reach out to me or the instructors. I know that you're all very busy, and I know you're all trying your best, and we love you all. So if you can't make this deadline, it's okay, but please try your best to do so. The reason we're asking for that is because we're actually starting the next boot camp on Monday the 6th. So literally on Monday, we're starting, or like the next Monday, we're starting another boot camp. So please try to get your quests in before June 5th, which is next Sunday. So when you do that, all the instructors, we're gonna, please, when you finish your quests, type in the quest submissions chat, ping Academy instructors, and type like "I'm done," and then we'll add you to a final list, and we're gonna airdrop you your final certificate float for completing the boot camp. And then once you'll do that, you'll have access to the graduate channel. And so when you're in the graduate channel, there's two things that'll happen. One, you'll have, pretty much forever access to, us and the instructors to answer questions about your projects. If you find a job in the Flow ecosystem and you have questions about anything, you can always come back to Emerald Academy and ask us about that. Or, the graduate channel will also help you try and find a job in the Flow ecosystem. We're going to have some recruiters in that channel. Again, we don't promise anything, but we're going to do our best to get some graduates, get some recruiters in there. In fact, during the last boot camp, I think 20% of our graduates actually got a full-time job. So, again, no promises, but we'll do our best to do that. And the next boot camp will begin on the 6th. It'll be the same exact boot camp. Even though it really won't mean much to all of you, we would love to have you back here. And if any of you want to be instructors, let me know. So I'm going to go over all this again during the next workshop on Friday, but I'm just letting you guys know, if you're thinking about quests and all that stuff. So no, the next boot camp will also be free. So even though we wanted to charge for it, they're going to be free again. Yeah, because we like getting to interact with all you, and we want you all to have fun. Until Jacob is broke. True. Very true. Yeah. Which float did I get, by the way? Oh my god, number 5. You guys are getting quicker and quicker. What the heck is going on here? Yeah, so that's all I have for all of you. Thanks so much. We have our town hall on Sunday. So if you're interested in getting to learn more about Emerald City or Emerald Academy or all the amazing projects we're working on, please come to our town hall on Sunday. We always have a lot of fun, exciting things going on. And I guess look out for Dapper Wallet and Emerald ID either tonight or tomorrow, most likely. So have fun, everyone. Love you all, and see you on Friday. Bye.